This is lecture 131B in the ABCs of Communism series. This particular set of lectures is in support of the forthcoming Volume 8 on communism in North America prior to the arrival of the whites. And our subject this morning is the agricultural revolution in the eastern woodlands. Now, there were several independent regions of plant domestication in the Americas, as you well know by now, and different species of the same genus were domesticated independently in different regions and by different peoples. Sometimes the same species was domesticated several times in different parts of the range of a widespread wild progenitor. These different domesticates show similar changes resulting from human selection. Different domesticated genotypes could eventually be combined to produce a new domesticate. Now, the Americas have contributed a number of crops of major global importance. For example, maize, that is corn or zea maize, potatoes, Solanum tuberosum, cassava, Manihot esculenta, and the common red bean, Phaseolus vulgaris. Other species in the same genera have been used, sometimes quite intensively but never fully domesticated, or have remained only minor crops. Now, 5 New World regions have been independent areas of crop domestication. Several species in western North America, several species in eastern North America, many in Mesoamerica, the Central Andes, and Amazonia. Now, in terms of origins in eastern North America, by 2,800 years ago, people cultivating several species of plants on the road to the stage of agriculture were extant. Now, after 200 BC, maize had been carried along the mountain and coastal highway of northeast Mexico and adjacent USA into the woodlands of the eastern continent. The 4 main plants already domesticated were goosefoot, that is Chenopodium berlandieri, sunflower, Helianthus annuus of the variety Macrocarpus, the marsh elder, Iva anna of the variety Macrocarpa, and squash. Now, cucurbita, species of the ovifera, and several other species of plant were also domesticated, but of lesser importance. With the arrival of maize, these people were quick to accept corn agriculture and the cultivation of indigenous plants declined. Now, most were eventually abandoned, and formerly domesticated plants reverting to their wild forms. At the end of this lecture, we'll take a look at one of those, which is of particular interest to me, and I think there's no point in going through more than one, but maygrass is certainly one of them, which is a weed today, but was very important at one time. Now, during the last half of the 20th century, the leaders of our discipline of archaeology accepted the concept of an autochthonous stage of incipient tribal agriculture that became full-fledged with the arrival of corn. Squash, that is Cucurbita pepo of the variety Ozarkana, is considered to be one of the first domesticated plants in the eastern woodlands, and it dates to 7000 BP. The squash that was originally part of the agricultural complex was raised for edible seeds and produced small containers, or gourds. Now, Cucurbita argyrosperma had been dated to 3500 BP. Other seed pepo cultivars, such as crookneck, acorn, scallop squash, little barley, the Hordeum pusillum, goosefoot or lamb's quarters, Chenopodium berlandieri, erect knotweed, Polygonum erectum, maygrass, which we're going to look at more closely later, Phalaris caroliniana, marsh elder, Iva annua, and sunflower, Helianthus annuus, followed shortly thereafter. The plants are often divided into oily or starchy categories. Sunflower have edible seeds rich in oil. Erect knotweed and goosefoot, a leafy vegetable, are starches, as are maygrass and little barley, both of which are grasses that yield grains that may be ground to make flour. The archaeological record proves that humans were collecting these plants from the wild by 8000 BP. In the 1970s, archaeologists noticed differences between seeds found in the remains of prehistoric Native American hearths and houses and those growing in the wild. In a domestic setting, the seeds of some plants were much larger than in the wild, and the seeds were easier to extract from the shells or husks. Now this was evidence that indigenous gardeners were selectively breeding the plants to make them more productive and accessible. The region of this early agriculture is in the middle Mississippi Valley from Memphis north to St. Louis and extending about 300 miles east and west of the river, mostly in Missouri, Illinois, Kentucky, and Tennessee. The oldest archaeological site known in the United States in which Native Americans were growing rather than gathering foods is Phillips Spring in Missouri. At Phillips Springs, dating from 5000 BP, archaeologists found abundant walnuts, hickory nuts, acorns, grapes, elderberries, ragweed, bottle gourd, and the seeds of cucurbito pepo, a gourd which, as we have seen, has the edible seeds, which is the ancestor of pumpkins and most squashes. The seeds found at Phillips Spring were larger than those of the wild seed pepo. The agency for this change was surely human manipulation. Humans were selecting, planting, and tending seeds from plants that produced larger and tastier seeds, and ultimately they would manipulate cucurbita pepo to produce edible flesh. By 3800 BP, Native Americans were cultivating several different plants. The Riverton site in the Wabash River Valley of Illinois, near the present-day village of Palestine, is one of the best-known early sites of cultivation. 10 house sites have been discovered at Riverton, indicating a tribal agricultural stage population of 50 to 100 people. Now, among the hearths and storage pits associated with the houses, archaeologists found a large number of plant remains, including a large number of seeds of chenopods of the Goosefoot variety that were cultivated. Some of the chenopod, Chenopodium berlandieri seeds had husks only a third as thick as those of the wild seeds, because Riverton farmers had bred them selectively to produce a seed easier to access than wild varieties of the same plant. These grew to 5 feet in height, with many branches of tiny seeds at the end of each, which were then harvested. Another domestic plant species at Riverton was the sunflower, Helianthus annuus. Other domesticated plants at Riverton include the bottle gourd, Lagenaria, Ciceraria, squash, Cucurbita pepo, wild barley, Hordeum pusillum, and marsh elder, Iva annua. 3 of these domesticate chenopods, L. annua and Cucurbita pepo, were plants that thrived in disturbed soils in river valleys. In the aftermath of a flood, these pioneer plants sprang up. Now, Native Americans learned early that seeds of these 3 species were edible and easily harvested in quantity because they grew in dense stands. Cucurbito pepo was important also because the gourd could be made into a lightweight container. Chenopods have edible leaves related to spinach and chard that was gathered and eaten. Chenopod seeds are starchy, and marsh elder has a highly nutritious, oily seed similar to sunflower seeds. Now, humans selected these plants to become productive, and this is the process of domestication. The seeds of those selected became larger, and their seed coats less thick compared to the wild plants. For example, the seed coats of domesticated Chenopodium are less than 20 microns thick. The wild Chenopodium of the same species is 2 to 3 times as thick. By 2500 BP, seeds produced by 6 domesticated plants were an important part of the diet in the middle Mississippi River Valley of the USA. The indigenous crops were joined by crops developed in Mexico. Especially important were maize, beans, and additional varieties of squash. Maize, or corn, was a relative latecomer to the eastern USA. The oldest known evidence of maize in Mexico dates from 8700 BP. We discussed all of this in Volume 2. Maize was first grown in the eastern United States around 200 BC. Highly productive adaptive strains were widely used around AD 900. Now, there are 3 autochthonous domesticates in eastern North America that deserve our immediate attention. The first is the gourd, Cucurbita pepo ovifera. Besides its edible flesh, it was useful as a container and fishnet float in a riverine and coastal environment abundant in fish and shellfish. Nevertheless, it was gathered as a food staple as well, and its oil-rich seeds would have been eaten. Vegetable forms like crookneck, acorn, and scallop squashes developed later. Marsh elder, Iva annua, and sunflowers, Helianthus annuus, were also domesticated for their oil-rich seeds. The first sign of domestication in all three is the appearance of large seeds or fruits outside the range of modern wild forms. Common gourds of Cucurbita pepo and sunflowers are still important crops, but marsh elder had disappeared from cultivation by the time of white contact. Eastern squash was an indigenous gourd, autochthonously domesticated along with sumpweed, chenopod, and sunflower. Cucurbita squash is found in archaeological samples throughout the eastern USA and Canada and is older than bat cave corn. Eastern North America was a precocious, independent center of domestication. Now there is another one I want to take a closer look at, an autochthonous domesticate number 4. Seeds of the fourth domesticate, Chenopodium berlandieri, are not significantly larger than those of wild chenopods. Chenopods are members of the amaranth family. Humans have been eating chenopods for over 6,000 years. Goosefoot is easy to identify with its tall green growth and purple tips and blooms. Its wild form grew without any help from humans and could be eaten raw or cooked just like spinach. Pit seed goosefoot, that is Cucurbita berlandieri, was a staple crop for many eastern Native American peoples. Once this plant appeared in its normal life cycle, it was an obvious choice for food gathering and then horticulture. The next time you see a weed with purple edges and flowers, take a closer look before cutting it down. In North America, California goosefoot, that is Blightum californicum, also known as lamb's quarters, is a close cousin to spinach, and like spinach, goosefoot contains a lot of calcium and other minerals. Now there were other autochthonous domesticates cultivated, but are no longer so. These include buckwheat, Polygonum erectum, giant ragweed, Ambrosia trifida, maygrass, Phalaris caroliniana, little barley, Hordeum pusillum, wild rice, Zizania palustris, and Jerusalem artichoke, Helianthus tuberosus. Now, from horticulture to agriculture. Cutting or uprooting was the preferred primitive communist harvest technology for the eastern North American seed crops. Both techniques favor loss of seed dispersal in most of the cultigens of eastern North America. Increased size of seeds, which in many Old World crops precedes loss of dispersal, also has not occurred in many of these putative cultigens. Now, modern wild populations of L. annua, C. berlandieri, and P. erectum have grain yields comparable with those estimated for prehistoric North American maize. In eastern North America, potential crop species other than these 4 domesticates remained at the stage of horticultural cultivation. In the eastern United States, we have a series of radiocarbon-dated original domesticates. These are squash, Cucurbita pepo, that was a highly valued domesticated plant, as we have seen, by 5,025 years BP, sunflowers, Helianthus annuus, by 4840 BP, marsh elder, Iva annua, by 4,400 BP, and corn, or maize, arrives around 2150 BP. Now, by 2000 BP, the following were cultivated domesticates: erect buckwheat, Polygonum erectum, little barley, Hordeum pusillum, and maygrass, Phalaris caroliniana. Now we want to take a look at the 2 most important sites, Riverton and Koster. Excellent evidence comes from the Riverton site in southeastern Illinois dating to 3800 BP. The Riverton site is an archaeological site located immediately west of the Wabash River and northeast of Palestine, Illinois. The site, which dates from the late Archaic period, is the type site of the Riverton culture. The Riverton culture, of which only 3 known sites have been discovered as of 1978, inhabited the central Wabash Valley and had distinct methods of making tools. The remains at the Riverton site can be separated into 2 areas, a manufacturing area with pits and a significant number of discarded tools, and a residential area with the clay floors of homes. The Koster site is a deeply buried archaeological site located on Koster Creek, a narrow tributary stream incised into the alluvial deposits of the lower Illinois River Valley. This Illinois River is itself a major tributary of the Mississippi River in central Illinois, and the site lies 30 miles north of where the Illinois meets the Mississippi today at the town of Grafton. The site exhibits well-preserved human occupations dating back 9,000 years. Now, taking a closer look at Riverton archaeology, good conditions of preservation, large-scale archaeological excavation, and a deliberate search for plant remains provided documentation of the utilization of a rich diet and the cultivation of 7 different crop plants. In addition to the species listed above, there are 2 varieties of chenopod, Chenopodium berlianderi, abundant in the archaeological botanical remains from the Riverton site. The Riverton formative archaeological revolution features a crop complex that was the result of a lengthy proto-archaic and archaic experimentation with different combinations of domesticates and wild foods. The breakthrough at the Riverton site came because of a congruence of preservation, large excavation, and an intentional search for plant remains. The agricultural formative revolution evidence dates to 3,800 BP at Riverton. By this time, people had developed a rich diet that featured cultivation of 7 different crop plants, including 2 varieties of the chenopod species, Chenopodium berlianderi, the remains of which were abundant in the archaeobotanical samples from the site. A crop complex for plant or animals represents the end result of long experiments with different combinations of domesticates and wild foods to find a coherent whole in terms of reliable food supply. Eastern North America's agricultural revolution began by 3,800 years ago in the lower Illinois River Valley. 7 crops were harvested there by that time. These were bottle gourds, sunflowers, marsh elders, and 2 varieties of chenopod. Natalie Mueller is an archaeologist at Cornell University who has spent years hunting for the erect knotweed form of buckweed, that is Polygonum erectum, across the southern U.S. and into Ohio and Illinois. I consider her to be the leading authority at this time and recommend her publications as listed in her Cornell CV. Now, native to the Americas, erect knotweed grows in the moist flood zones near rivers. It is a stocky plant with spoon-shaped leaves, and it produces achenes, or fruit, with very hard shells to protect its rich starchy seeds. Though rare today, the plant was common enough 2,000 years ago when Native Americans collected it from the shores of rivers and brought it with them to the uplands for cultivation. Archaeologists have found caches of knotweed seeds buried in caves, clearly stored for a later use that never came, and in ancient fireplaces. They have found burned, erect knotweed fruits popped like corn. Mueller says erect knotweed was domesticated on tribal family farms on the western front of the Appalachians. There are clear differences between it and its feral cousins. After years of comparing the ancient seeds with wild types, Mueller has found 2 unmistakable signs of domestication: larger fruits and thinner fruit skins. We see a similar pattern in other domesticated plants like corn, whose wild version with tiny seeds is almost unrecognizable too in the large kernels of the contemporary domesticated plant. Now, obviously, bigger seeds would make the erect knotweed a better food source, so farmers selected for that. And the thinner skin means the plants can germinate more quickly. Their wild cousins evolved to produce fruits tough enough to endure river floods and inhospitable conditions for over a year before sprouting. However, farm life is easy on plants, so these defenses were not necessary for their survival under human care. Now for the Koster archaeology. In 1968, Stuart Strever was a faculty member in the anthropology department at Northwestern University in Evanston, Illinois. Strever's investigations from 1969 to 1978 at Koster Farm revealed not only the middle and early late woodland materials reported by the Kosters, but a stratified multi-component archaic period site of astonishing depth and integrity. I met him at an Ethnological Sciences Congress in Chicago in 1972 when he was in the middle of his intensive investigation. I realized then that Koster was going to be the key to unlocking the sequence leading to the stage of tribal agriculture in the eastern woodlands. Now, beneath the Koster farm lies evidence of 25 different human occupations, beginning with the early Archaic period around 7,500 BC and ending with the Koster farm. Now, village after village, some with enterprise cemeteries, some with houses, beginning some 34 feet below the modern Koster farmstead. The deposits of the river, each occupation leaving its mark on the landscape nonetheless, buried each occupation. The best studied occupation is the set of early Archaic occupations known as Horizon 11, dated 8,700 years ago. Now, archaeological excavations at Horizon 11 have revealed a thick midden of human occupation residues, basin-shaped storage pits and hearths, human graves, diverse stone and bone tool assemblages, and floral and faunal remains resulting from human subsistence activities. Also on Horizon 11 were the bones of 5 domesticated dogs, representing some of the earliest evidence for the domestic dog in the Americas. The dogs were purposely buried in shallow pits, and they are the earliest known dog burials in North America. The burials are essentially complete. All of them are adults. None exhibit evidence of burning or butchery marks. Now, at the surface, Koster covers 3 acres, and its deposits extend more than 30 feet into the alluvial terraces of the river. The site is at the contact between the limestone bluffs and upland lush plains to the east and the Illinois River floodplain to the west. Occupations present within the deposits date from early Archaic through the Mississippian period, radiocarbon dated to between 9,000 to 500 years ago, a very long sequence. During most of the prehistoric occupation of the site, the Illinois River was 3 miles to the west, with a seasonally fluctuating backwater lake within 1/2 mile. Chert sources for making stone tools are in the nearby limestone bluffs lining the valley and include Burlington and Keokuk, sources which vary in quality from fine-grained to coarse-grained. Beneath the Koster farm is evidence, then, of 25 different human occupations beginning with the early Archaic period around 9,500 years ago and ending with the Koster farm. Village after village, some with cemeteries, some with houses, beginning some 34 feet below the modern Koster farmstead. The deposits of the river, each occupation leaving its mark on the landscape nonetheless, buried each of them. The first farmers summarized. Over 8,000 years ago in North America, indigenous people domesticated plants that are now part of our everyday diet, such as squashes and sunflowers. However, they also bred crops that have since returned to the wild, and these include erect knotweed, not to be confused with its invasive cousin Asian knotweed, goosefoot, little barley, marsh elder, and maygrass. We have not simply lost a few plant strains. An entire cuisine with its own kinds of flavors and baked goods has simply disappeared. By studying lost crops, archaeologists learn about everyday life in ancient woodland culture of the Americas, including how people ate plants that we call weeds today. These plants give us insight on social networks. Scientists can trace the spread of cultivated seeds from one tiny settlement to the next in the vast eastern woodlands, which groups were connected culturally, and their kinship alliances. As you have seen, the indigenous North Americans of the eastern woodlands had a unique crop system now known from archaeological investigation. Growth experiments and observations of living progenitors of these prehistoric crops provide the necessary insight into the ancient agricultural system of eastern North America. By this insight, I mean the role of developmental plasticity in the process of domestication and the creation and maintenance of diverse species and varieties under cultivation. Now, in your textbook, when you get it, what comes next is what is the archaeological sequence of 25 distinct archaeological strata at Koster that provide a framework from which to build our sociocultural evolutionary framework for the agricultural revolution onwards, beginning with Horizon 1, Mississippian, AD 1000 to 1200, and then going deeper until we get to Horizon 14, which is sterile. There's no point in going through each one of those one by one here. You'll have it in the text when you get there. But I did want to take out one particular a species as an example, and that's Phalaris caroliniana maygrass from the family of Poaceae. The fruits, the caropsis of Phalaris caroliniana, have been identified from archaeological sites ranging from Alabama to southwestern Indiana and westward to Arkansas, Oklahoma, and Texas, whose dates of occupation span 4,000 years. Maygrass is a member of the eastern North American starchy seed complex, where the domesticated status is not yet known. Now, the description. The caropses are the most common part of maygrass plants recovered from archaeological sites. Mature fruits average between 1.8 and 2.3 millimeters in length and range from 0.9 to 1.8 millimeters in width. Experiments indicate that maygrass fruits shrink an average of 10% after carbonization. Maygrass caropses are ovoid, elongate, and have basal, laterally located embryos. The embryo is often absent in charred fruits, resulting in a distinctive silhouette. Sometimes the sulcus, which runs along the hilum-bearing side, is observable on archaeological specimens. Charred caropses occur singly or in clumps and are commonly recovered from open-air sites. Rock shelters and caves have yielded uncarbonized maygrass fruits, inflorescences, and stems. Bound bundles of maygrass inflorescences have been recovered from a number of eastern rock shelters. Uncharred fragments of maygrass florets are common constituents of human paleofeces from Salts and Mammoth Cave, Kentucky. Maygrass first appears in the archaeological record in eastern North America during the late Archaic period. The Bacon Bend site, 4400 BP, located in the lower Tennessee River Valley, provides some of the earliest maygrass known. Feature and midden samples from this short-term campsite yielded 130 carbonized maygrass seeds, that is, caropses without pericarps. Phalaris species caropses that date earlier have been recovered from Koster at 8,250 BP and Campbell Hollow at 7,600 BP sites in Illinois. 444 maygrass grains were identified from an AD 1680 Native American village in the North Carolina Piedmont. Increased representation of Phalaris caroliniana in sites in Tennessee and Illinois during the Woodland period indicates it had become an important crop by this time. Maygrass is a major constituent of the early and middle Woodland period archaeobotanical assemblages in the lower Tennessee Valley, and it occurs to a lesser degree in early Mississippian and historic period sites. In the American bottom, maygrass increases in importance along with other starchy seeds during woodland times. Maygrass continues to be an important component of ICT2 assemblages into the early Mississippian period, when its occurrence, along with other starchy seeds, sharply decreases. A near absence of maygrass grains from the west central Illinois sites earlier than Middle Woodland was followed by its abundance later. And some final comments on the modern plant and its distribution. P. caroliniana is an erect annual which ranges from 0.2 to 1.2 meters high and terminates in a panicle which can reach lengths of 9 centimeters or more. Natural populations of maygrass begin to flower in early April, and caryopses mature during May and June. Ripe fruit is reddish-brown in color and tightly enclosed in its surrounding palea and lemma. Maygrass is currently distributed throughout the southern half of North America and northern Mexico. In the United States, it grows predominantly in the southeast, but does occur rarely in areas farther north. And although maygrass grows in a variety of habitats, it tends to favor disturbed environments. Human feces provide the most convincing evidence of prehistoric consumption of maygrass. Paleofecal samples from Mammoth, Salt's Cave reveal maygrass to have been a common component of the diet during early and middle woodland times. Harvesting and nutritional studies demonstrate Carolinianus to be a nutritious crop. Despite the archaeological abundance and economic potential of maygrass, argument for its intentional propagation by prehistoric people hinges upon the disjunction between its archaeological and modern geographical ranges of occurrence. And with those comments, I'm going to conclude this particular lecture on the origins of agriculture in the eastern woodlands of the USA, which is also the end of primitive communism. That is, tribal agriculture is the last stage of primitive communism. And we're going to pursue tribal agriculture and early chiefdoms in the next lecture. And then the one following that will go from the simple chiefdoms to the advanced theocratic chiefdoms of the eastern woodlands. So that takes care of that for today.